Last time we saw how an electron moves randomly in a metal wire while following an overall direction opposite of the electric field. This is a great picture, but it differs from reality in two important ways. First, real wires don't extend on forever, but have edges that the electron cannot pass. And second, a real wire has many electrons all moving under the same rules. Here we have made these two additions to our code. We create a wire by using the makeWire function and providing the wire's position, length, width, and direction of current flow, along with the metal's resistivity and electron density, and the voltage applied across the wire. Then we create a large number of electrons, each at a random location and moving at a random velocity. These electrons obey the same scattering rules from the previous episode. We've also added a feature where electrons can jump from one end of the wire to the other. This basically means the wire is infinitely long. We've also turned our calculation of average velocity into the current in the wire. We can easily see that increasing the voltage across the wire will increase the current. We can also increase the current by decreasing the wire's resistivity. You can also try changing the size of the wire. A longer wire will show a lower current, while a wider wire will show a higher current. You might be wondering why the size of the wire would change the current inside it. The activities at the link in the description below will help you explore how.